First of all, thanks for inviting me to this webinar. As Pedro anticipated, I am from the University of Murcia. I am a postdoctoral researcher, and in this presentation, I would like to explain how we try to propose trust as a new intent to be combined with other well-known intents, like, for example, security. You will comment it previously in one of the previous presentation, or other like cost, location, etc. So what we thought is, okay, can we guarantee trust in an automated and multi-domain 6G network? That basically was the question that arose in our head when we were working on XIX, that is one of the 6G flagship project in which trustworthiness, that is KPI, was set there. 6G network in general will bring us plenty of new technologies or use cases, scenarios, and even paradigms, like, for example, the computing continuum or the cloud continuum. In this specific one, it is characterized by features like, for example, try to provide end-to-end services using multi-stakeholder solution or multi-domain. And in this point, it's really important to set the trust before establishing an end-to-end connection, because we may have different providers offering similar services or network services or solution in general. And it's really important to determine which could have a better behavior in the future before signing a smart contract. And regarding smart contract, in particular, the service level agreement, this kind of contract that you were previously commented, there is a missing point from our point of view. It's like there are plenty of characteristics as part of the SLA, but the behavior, the historical behavior of the resources or the stakeholder that the resource may belong, is not part of them. Maybe that is one of the reasons why trust has not been considered as an intent for IBM solution. In order to explain our work, I will follow a Ishikawa diagram that basically is like a fishbone diagram that organizes the different points, like the coast or the bones, and we are going to try to converge all of them on the effect that in our case is to provide trust as a intent in order to orchestrate the networks. So, but what is the problem, or what is the principal activity that we want to tackle with this presentation? Okay, we would like to offer to end users the capability to type using natural language trust-oriented requirements that we are going to convert in adaptation of the SLA that we call trust level agreement, that basically is like an extension, I will say. And once we have an agreement, we will try to monitor in real time those trust features and apply some rewards or punishment depending on the behavior of the network service in order to adapt the level of trust. Of course, this is the outcome, this is the system, but we achieved this system thanks to 4 different articles and 2 projects in which we were working. So let's start for the first bound, that is requirements. So first of all, we needed to deal with how can we gather requirements from end users, in particular trust requirement. For this end, we use Rasa open source framework because it's a tool oriented to network management, and also this tool introduces flexibility for developers in order to configure from scratch the name entity recognition model. In this regard, we define 4 different intents. The first one, for example, the build, basically is to user may request a network service under this intent, and then the system will try to start the functionality. Then we have other intents, like, for example, feedback, in order to adapt the output from the interpreter, from the Rasa framework, just to guarantee that the interpreter is fulfilling the end user requirements. and then confirm or reject once we have, let's say, a stable conversation with the interpreter. In addition to that, we also have entities that they are different keywords that we would like to identify in the sentence. Like, for example, the operations, that basically they are the actions that an user may, let's say, ask. For example, to deploy a service, to add a service, delete, configure, reconfigure, etc. Then we have the middle boxes that they are basically the assets to be deployed. For example, a service, a DNS, a firewall, and for example, the services that they are the software for these middle boxes. We have other kind of entities that we are in charge of, or we would like to identify, but they are, let's say, more common, like the quality of service and storage capabilities and so on and so forth. To minimize the number of loops that we are interacting with the end user, we have different fallback approaches. Like, for example, we have a first classifier, the DICE classifier, that basically assign some confidence score to the predict intent that the system is forecasting in the sentence. And then we have the fallback classifier that basically, once we have the prediction, we identify the different tokens and we determine how much such a token may match with the different entities or the different intents, depending on the keyword. And we have some thresholds. If the score is below the thresholds, we will start the feedback loop, just to guarantee that even is below, we are, let's say, matching a keyword with a specific entity or with a specific intent. The second bone of our solution is the semantic part. During the literature review, we try to analyze if there is a ontology that can fulfill at the same time different dimensions. That basically is to introduce trust management concept together with IBM ideas plus the cloud continuum or computing continuum vocabulary. So in the literature, we found different IBM-oriented ontologies or trust management ontologies, but we didn't identify a unique solution combining these three dimensions. That's the reason why we used the linked open tent methodology that allow us to reuse some part of ontologies already existing, and they are properly covering all objective, into a ontology that we are extending with this concept that we may see here, among others that they are available in the LinkedIn. So in this sense, we are trying to maximize the interoperability because we are reusing some ideas and we are asking ourselves some competency questions. That is the way to extend ontology, having in mind different profiles. Like, for example, the view of a developer, the view of a domain expert, or the view of a, for example, project manager, to put some examples. And then the third bone is basically to create a contract. And as I said, we define a new concept that we call it trust level agreement, that is like an extension of a SLA. So we have some similar features, like, for example, the provider ID or the consumer ID, but we introduce new parameters. For example, the trust metrics. We introduce the level of trust that an end user may request, the reputation, for example, that is a number in charge of compute the overall level of trust based on the previous behavior or the feedback on a specific network service or stakeholder that we may receive from a third party. Of course, we also add some thresholds. We can include even the evidences, the raw data that we are going to gather later, and they are part of the ontology that I previously commented, and the actions to be executed if the TLA is not fulfilled during the life cycle. At this point, what we try to do is, okay, let's identify if the interpreter is working well with the different intents and the different entities that we previously defined. For this purpose, we use a BERT language model for the intents, for the 4 different intents that we may observe on the left-hand side in this plot here. And since they are not too much intents, the model worked more or less good, even though we needed to apply some additional techniques, like for example, extend the intent sample with synonyms, because sometimes end user may use different words to say, I want to create, or I want to build, I want to construct a different service. So finally, we achieve more or less an 88% of F1 score. Regarding the different entities, that they are the 7 categories that we may observe on the right-hand side, we were using LLM, BERT LM, that is the orange bar, with Lumi, that is an existing solution for intent-based systems. But we identified that finally the conditional random file, that is an algorithm, worked better than these 3 ones. So for this part, for the entity recognition, we use CRF. Then it's time to start to monitor. When we have signed the contract, is the time to observe if the different providers are fulfilling the contract. To this end, we use available RFC, in particular the RFC 4917, that is oriented to service assurance for IBM solutions. In order to, let's say, use this RFC, we needed to develop 3 different components. First of all, a rule recommender that I will explain later, in order to activate or deactivate predefined rules to be monitored. The DX agent, that basically is the entity in charge of gathering real-time data. And here we have 5 different dimensions that we are monitored. We monitor the CPU, the disk, the processes in the system, the memory, and the network. We may zoom in this dimension and extract basically any kind of information that we may collect from the system per se. After that, we have the DX collector, that is the entity in charge of obtain those metrics and push them to Kafka through a GNMI, that is basically a gRPC, but for network management interfaces. But how are we computing the trust score that an end user may request? So we have 2 different concepts, and they are different ideas, but at the same time correlated. So on the left-hand side, we have the health score, that is a value that we compute per dimension. Remember that we have the 5 dimensions, the CPU, the memory, the processes, the disk, and the network. So we have 1 health score per dimension, because each dimension may have activated more than 1 rules. We may observe different features under the same dimension. So we combine all those rules, we create the health score of such a dimension, and then we apply some punishment depending on the severity that we are observing, because we have some thresholds that each dimension must fulfill, and if it's below, depending on the decrease below the threshold, we will apply some punishment or others. Then we combine all this health score and we compute the level of trust. That is the value that an end user may request between 0 and 1. Here it's really important to adapt the weighting factor that we have. For example, the weighting factor on the left-hand side regarding the current health score. Why? Because the higher value of beta, the more reactive the system will be to current failures or current changes in the end-to-end connection. In contrast, the lower value to beta, the more stable the system will be, or I will say that the changes will affect less than the historical data that we gathered in the past. And finally, we modify the RFC because one of the principles under this RFC is that we have a set of rules, and all of them are activated by default. So the system is gathering at the same time features for the CPU, the disk, the memory. So basically, we are not contemplating the specific requirements from end users. So we try to introduce some intelligence here, and we thought, okay, let's try to analyze if we can apply a dual approach that basically is combine semantic similarity with the well-known LLMs, and see if we may enhance this, let's say, recommendation instead of only use one of these mechanisms, semantic or LLMs. So here we may observe how they are working in isolated way, I mean, without any combination. And it is true that LLMs can be really difficult to manage in terms of cost. For example, if we need to apply some fine tuning, but it is not our case. So we try to test different LLMs like GMA3, but also DeepSeek or Orca, and we observe that GMA3 obtain the best results. And we say, okay, sometimes LLMs unfortunately have some hallucinations. So let's try to see if we can combine with the semantic similarity, and we cannot at least decrease the F1 score that an LLM by itself can achieve. And playing with the different weighting factor, we observe that if we assign a 40% to the BM25, that is the semantic approach, with 62 GMA3, we can enhance the F1 score. Of course, it can be, we can work on better results, but at least as first round of, let's say, outcomes is something acceptable for us. Finally, just to conclude, we checked the whole system from the beginning to the end, from, I mean, when a user write or type trust-oriented requirements until the ontology that at the same time is our knowledge graph is being, I mean, feed with the data that we are gathering in real time. And we observe that, I mean, without the orchestration percent in the deployment of the machines in different domains, omitting this part, let's say, we consume less than 1 second. That at the end is something acceptable to be combined with the pure orchestration that consumes more time. But our thought was, okay, we are not introducing too much delay on a system that is, let's say, huge, like the orchestration activities. So what are the conclusions? So we proposed some of the, I mean, initial solutions to include trust together with other intents, like for example, security, cost, location, etc., as a way to orchestrate networks. We are providing also an ontology that can be extended, can be reusable because it's totally available, and we are using well-known ontologies in the field. And we validate with the previous experiment, but we also include here. Well, we didn't include in this presentation. What we try, we did it with other university, that trust can be used together with risk assessment models in order to explain what is happening. Because, for example, we are decreasing the value of trust because we observe that the CPU is obtaining more, I mean, resources that we assume. But we don't know why, because we are not a threat detection model. But if we apply some risk techniques to identify vulnerabilities in the system, we can explain why a risk is associated with the trust and in the other way around. So we are complementing each other. Finally, these are the references that I use. That's all from my side. Thank you for your attention. And if you have any question, I am happy to answer them. Thank you.